हेलो चिल्ड्रन, आज से हम लोग नया चैप्टर स्टार्ट करेंगे. चैप्टर 7th B, इक्विलिब्रियम पार्ट 2, and the name of the chapter is Ionic Equilibrium. So in this chapter we will study the reactions in which ions are involved. Okay, so equilibrium in ionic equations we will discuss in this chapter, and also some related topics. The first heading of the chapter is electrolytes and non-electrolytes. So electrolytes are the substances which conduct electricity in fused state. Fused state means molten state, and in aqueous solution are called electrolytes. Okay, so electrolytes are ionic compounds, or you can say electrovalent compounds, which show conduction of electricity in their fused state or in aqueous solution state, means solution in water. Then second type of substances are non-electrolytes, and these are the substances which do not conduct electricity in their fused state or in aqueous solution state. Okay, like sugar, glucose, urea, etc. So these substances are covalent in nature, covalent compounds. Okay, the next heading, classification of electrolytes. So electrolytes are classified under two headings. The first is strong electrolytes. So these are the electrolytes which dissociate completely in aqueous solution condition. Dissociate completely in aqueous solution condition. So these substances will form ions only in their aqueous solution. For example, if you will dissolve NaCl in water, so when you dissolve NaCl in water, then you will get only sodium and chloride ions present in water. Okay, because all the part you taken NaCl will be dissociated in the form of ions. So finally only ions will be present in water. Weak electrolytes. These are the substances or ionic compounds which dissociate partially, okay, in a small extent in aqueous solution, and so conduct electricity to a small extent, are called weak electrolytes. So you all know that amount of electricity conducted by an electrolyte is directly proportional to the number of ions or concentration of ions in the solution. So strong electrolytes, due to their complete dissociation, are having a larger number of ions in aqueous state, and that is why strong electrolytes are very good conductor of electricity, whereas weak electrolytes which dissociate partially in the form of ions, and that is why due to the low concentration of ion aqueous state, they are the weak electrolytes, and also conduct electricity in a small extent only. For example, ammonium hydroxide, it is a base, and all such bases which are having number of hydroxide ions 2 or more than 2. For example, ferric hydroxide, ferrous hydroxide, chromium hydroxide, etc. And all the organic acids like formic acid, acetic acid, butanoic acid, etc. Amines also there. Okay, so when we dissolve these electrolytes in water, they dissociate partially in ions in aqueous state. So what is ionic equilibrium? equilibrium involving ions and unionized molecules is called ionic equilibrium. Means if you are going to take 4 moles of acetic acid here, so all 4 moles will not dissociate in the form of ions. Out of 4 moles, a few moles will be present in water in the form of undissociated molecules, and the state of equilibrium will be present between undissociated molecules and dissociated molecules. Okay, so such type of equilibrium which is present in these such reactions is studied under ionic equilibrium heading. Okay, then degree of dissociation. Degree of dissociation, this term is originated because we know that जो वीक इलेक्ट्रोलाइट होते हैं वो कम्प्लीटली डिसोशिएट नहीं होते हैं. ठीक है, तो जितने भी मॉलिक्यूल्स हम किसी वीक इलेक्ट्रोलाइट के लेंगे वो सब के सब आयंस में डिसोशिएट नहीं होंगे. तो डिग्री ऑफ डिसोसिएशन क्या होता है? इट इज़ द रेशियो ऑफ द मॉलिक्यूल्स ऑफ एन इलेक्ट्रोलाइट इन विच द नंबर ऑफ मोल्स डिसोशिएटेड divided by total number of moles taken. This ratio is known as degree of dissociation and represented as alpha. So the fraction of the total number of molecules dissociated into ions is called degree of dissociation. Okay, so the fraction which get dissociated in the form of ions. Same way we represent degree of association also. Association means, dissociation means separation of ions and association means joining of the molecules. Okay, and that also represented as alpha. So degree of association will be equals to number of moles associated divided by total number of moles taken. Okay students, but ये जो टर्म है डिग्री ऑफ एसोसिएशन वो अभी यहाँ बुक में नहीं है, बट ये भी एक टर्म हम यूज़ करते हैं और अल्फा से ही उसको भी रिप्रेजेंट करते हैं, डिग्री ऑफ एसोसिएशन. देन नेक्स्ट हेडिंग इज डिफरेंस बिटवीन डिसोसिएशन एंड आयोनाइजेशन. So dissociation is the process in which only separation of ions involve. Only separation of ions means ions are already present in the form of molecule, and in aqueous medium they just separated. So this separation of ions is known as dissociation, whereas in ionization two processes are taking place together. So ये जो दो processes एक साथ होते हैं उनमें क्या होता है? First formation of ion and the second separation of ions. तो ionization में formation plus separation of ions दोनों होता है, तो that process is known as ionization. Okay, so dissociation जो है वो आयनिक कंपाउंड्स का होता है और आयोनाइजेशन जो है वो पोलर कोवेलेंट कंपाउंड्स का होता है इन एक्वस स्टेट. फॉर एग्जांपल HCl ये एक कोवेलेंट कंपाउंड है और इसमें जो कोवेलेंट बॉन्ड प्रेजेंट होता है वो पोलर कोवेलेंट बॉन्ड होता है. जब HCl को हम वाटर में डिसॉल्व करते हैं तो वाटर जो है एक पोलर सॉल्वेंट है और वो क्या काम करता है? वाटर मॉलिक्यूल्स की प्रेजेंस में ये H एंड Cl जिनके बीच में इलेक्ट्रोनेगेटिविटी का डिफरेंस है और उस डिफरेंस की वजह से ये बॉन्ड पोलर कोवेलेंट बॉन्ड है. तो वाटर मॉलिक्यूल्स जो खुद पोलर नेचर के हैं वो इन Cl एंड H एटम्स को अपोजिटिवली अट्रैक्ट करेंगे, जिससे ये जो रिलेशन है कोवेलेंट बॉन्ड वो अनइक्वली ब्रेक होगा और ये शेयर्ड पेयर ऑफ इलेक्ट्रॉन क्लोरीन एटम के साथ चला जाएगा. तो क्लोरीन एटम जो है वो वाटर मॉलिक्यूल्स की प्रेजेंस में ब्रेक हो जाएंगे इन द फॉर्म ऑफ क्लोराइड आयन और H एटम्स जो है वो ब्रेक हो जाएंगे इन द फॉर्म ऑफ H+ आयन. So this process will be known as ionization.